Hello and welcome to another lecture for AI for retail executives. In this lecture, we're going to talk about the role of simulators in AI and how important it is to really think about it from a simulation standpoint when you can. So let's start with my first job out of college. My first job out of college was at a company called Lockheed Martin, and I worked on the Aegis missile defense system. And so this system was, God forbid, but let's say that North Korea launched a missile with a nuke on it towards U.S. Hopefully, what we would be able to do is we would have these CGs or DDGs that would launch a missile and intercept it and then knock that thing out before it even got close to the United States. And so that's what we tried to do. Now, we built this system. We've really worked on this system since 1960s in the SDI Reagan Strategic Defense Initiative, and we've been working on it ever since. To every new build, there's a new build that comes out every year of this system and goes to all the Navy destroyers, and it's none of this classified information, but we have to go and test to make sure that thing works. And so what we do is these flight test missions, FTMs. I mean, they are really expensive. I cannot tell you how much they are, but in the umpteen millions of dollars every single test. Well, you want to be able to try a lot of things and move fast and try to get to the optimal point. More iterations, the better the models will work. Well, what we learned was that we can build a simulator. And this simulator, I believe, is called Medusa. And so we would build this simulator. It would simulate the real world in very high granularity. And we can try a new build, run it in that simulation, make sure everything works, the algorithms work correctly, and then only then, after we've proven that it works, then we will go to a flight test mission to make sure it generalizes to the real world. So that's that example. Similarly, in self-driving car. So Waymo just announced they've been working on self-driving car for longer than any other company in the world, and maybe 20 years, and they have just come out. Their big announcement and there's thousands of engineers working on this. Their only announcement of 2021 was Simulation City, a big, massive simulator. Why? Because you want to iterate very, very quickly. Annotation is extremely expensive of all that imagery data. Running the model is actually very dangerous in case it was wrong. You don't want to be wrong. And so let me see here, Simulation City here. And so they built this simulator, which simulates a real world on how to, they're going to put this truck out into the real world. It's going to have all these different environments, some, green circles, and if you're a skier, some double black diamonds, examples, and see how it does. And we can run that infinitely. And it's very scalable, very low cost to do that test. And so that's how they plan to generalize their self-driving car. A friend of mine, again, Kazir Yunus, just started a company in the last 4 years. He was our partner at Y Combinator, and they just hit $1 billion valuation. The only thing they do is build simulators for self-driving car. Shows you how important simulators are. And my last and final example, outside of retail, is AlphaGo. We talked about this deep learning paper and how DeepMind beat Lee Sedol in this game of Go. The way they did it is they played billions of games of Go to try to learn the best way to play Go. And once they learned that, they brought that back to Lee Sedol and played the best model they could find against him and won. And so now finally in retail. So Focal Systems have been working very hard for a number of years on a massive simulator that will play the game of retail billions and billions of times. So, the average store manager is, let's say, 45 years old, and they got that job about 15 years ago. And so you have 15, the best store managers have, let's just say 30 years experience being a store manager, 365. And so they have 11,000 days of experience playing the game of retail. Well, our algorithms are going to have 1 billion days of being a store manager, and they have tried every single which way to play the game of retail and optimize the things that they were trying to optimize for. And so we talked about this before, but our maximization framework for retail is we're trying to maximize EBITDA over all time, so the sum over time, subject to my input. And so what are my input? What are my control vectors? I have shelf capacity. I can control how much of each product I have on the shelf. I have back stock. I have top stock, so I can control my forecast can be independent from shelf capacity, and so I can order a bunch and have it in the store. I have labor, and I have price, and all of these change over time. And so as the real world changes, I can play this game, and I can play it on a per store level. And so this is exactly the way that retail is going to go. And it's your algorithm versus mine. And it is exactly what happened to baseball with Moneyball. And if you've watched that movie, if you haven't yet, and that's what's about to happen to retail. Today, most retailers have, if this is time, if demand for a SKU looks like this, retailers use sales from last year to predict last year's demand and then to predict next year's demand. And so retailers, and then they'll provide their forecast F of S over T based on that. And maybe it changes per quarter. Maybe they're actually going to do something like this. And so this is your F for this SKU. Let's say Tide is your example. And the reason why it's much below what true demand is because your estimate, if you're going to use sales, you're missing lost sales. And so you actually don't know what real demand was because you may not have been in stock all the time. And if your average on-shelf availability is 90%, then you're underestimating demand by 10%. So maybe you're adjusting for that, but maybe it's not the same for every SKU. Some is 0%, some is 20%. You really don't know. And unless you have real-time on-shelf availability metrics, it's very difficult to estimate true demand. So you're underestimating demand, and so you're basically underselling, and you're under forecasting as well, potentially. And so if you're playing the game of retail, you can actually go and test these different things in a simulator first and play different strategies as the world changes. And you might measure that there's an increase in demand. And so we're going to try to fix that. And again, another thing is that this is roughly a straight line, definitely per quarter, because changing your forecast every day based on some optimization function, having humans do that would be intractable. Having a machine learning model do this is very tractable. And it does that today for high-frequency trading algorithms. It makes thousands of trades a millisecond, and it's constantly changing the position of the portfolio. And so these models will do that. And the granularity of time should not be per year, should not be per quarter, should not be per month. It should be per hour. And it's changing constantly what it believes the shelf capacity for all the SKUs are. And so that is what we see it to be the game of retail. And instead of this, which is a very underfit model, maybe it's going to try to track as close as it can to the actual forecast, to the actual demand. And it can measure both sides. If you're over forecast, then you'll sell less than you think you were going to. If you're under forecasted, then you're going to be out of stock more often. So that is, and so we highly recommend, if you don't use Focal Simulator, to use your own, to build your own, and use that environment to try new ideas for shelf capacity, for different labor schedules, for different forecast schedules, different pricing algorithms. And I think that's going to result in a much, much higher EBITDA than what you're doing today. All right, that's all we have for this lecture, and we'll see you in the next one. Thank you so much.